Hi everyone, welcome back to our video lecture series on the RA microcontroller. In this video, I'll show you how to use the event link controller on the RA0E1 board. The event link controller is a hardware module in Renesas microcontrollers that allows peripherals to trigger each other automatically without CPU intervention. It helps offload tasks from the processor, enabling faster and more efficient real-time responses. First, open the E² Studio IDE. Next, click on File, then choose New and select Renesas C++ project. Then select Renesas RA project. A new dialog box will appear where you can enter a name for your project. After naming your project, click the Next button. From this drop-down menu, select FPB RA0E1 board, then click on Next button. Then again, click on Next button. Now select Executable and No RTOS option. Now select Bare Metal Minimal, then click on Finish button. After that, IDE will take some time to create your project. By default, the IDE will open the FSP configuration file. Next, click on the Stacks tab. Then select the GPIO stack and open its properties. Here you can choose different ELC sources for the GPIO ports. Now click on New Stack, then open the System category and select the Event Link Controller ELC stack. Next, click on New Stack again, go to the Input category and choose the External IRQ stack. We will use this external IRQ as the event source. We will use the onboard user switch, which is connected to pin P200. Since this switch is pull-up, we will use falling edge interrupt detection. Now, if you click on the GPIO stack and open its properties, you will see that the IRQ we configured is now available as the event source to control the specific GPIO port. Just for demonstration, I'll remove the external IRQ stack. Once it's removed, you'll notice that the GPIO stack no longer shows an IRQ event source for the GPIO port. Now, I'll add the IRQ stack again and reconfigure it. After this, we don't need to change anything further. Finally, click on Generate Project Content, generate the source code. Now click on the Proceed button to open the C++ perspective. Next, expand the SRC folder and open the hallentry.c file. First, I'll define an FSP error_t variable. In the Project Explorer, expand Developer Assistance, then expand the ELC stack. From here, drag and drop the ELC open function call into the hallentry.c file. After that, use the assert function to make sure the ELC open call was successful. Now, in the Developer Assistance panel, expand the external IRQ stack, and then drag and drop the external IRQ open function call into the hallentry.c file. After that, use the assert function to ensure that the external IRQ open call executed successfully. Next, from Developer Assistance, drag and drop the external IRQ enable function call into the hallentry.c file. Again, use the assert function to verify that the external IRQ enable function call was successful. Now, under the ELC stack in the Developer Assistance panel, drag and drop the ELC event link set function call into the hallentry.c file. For the second argument, we select the peripheral that we want to link with the event. For the third argument, we choose the external event that will trigger the ELC controller, which in turn enables the linked peripheral. After that, use the assert function to verify that the ELC event link set function call was successful. Next, drag and drop the ELC enable function call into the hallentry.c file. And again, use the assert function to ensure that the ELC enable call executed successfully. Now, if you expand Developer Assistance and then expand the GPIO stack, you will see the normal I/O read and write function calls. At the end of the I/O port function list, you'll also find the event-related I/O functions. From there, drag and drop the I/O port pin event output write function call into the hallentry.c file. The ELC can only control specific ports on the microcontroller. If you open the FSP user manual and go to Chapter 5, API Reference, under Section 5.2.18.2 System and then open ELC, you'll find a table on page 4426 that lists the port groups available for ELC control for each microcontroller family. For the RA0 series, the ELC can control port 1 and port 2. On the FPB board, the onboard user LEDs are connected to port 0, which is not supported by the ELC. So I will use port 1, pin 3 to control an external LED, as in the event link function call we linked port 1. Next, select the output initial low mode for pin P103. After that, I will change the symbolic name for P103 to make it easier to identify in the code. Now, click on Generate Project Content again to generate the updated source code and then open the hallentry.c file. For the second argument of the function, we can use the pin name that we just defined in the FSP configuration file. For the third argument, we use BSPIO level high. Then use the assert function to make sure the function call was successful. After that, I'll define an empty while one loop. This will keep the processor stuck here so we can demonstrate how the ELC controller turns on the external LED when the onboard user switch is pressed. A quick recap of the source code. First, we call the ELC open function. Next, we use the IRQ open function, followed by the IRQ enable function. Then we link the external IRQ with port 1. After that, we enable the ELC. Finally, we use the event output write function to control the GPIO. Now, click on your project name and then click the hammer icon to build your project. Once the build is successful, right-click on the project name, select Debug As, and then choose Renesas GDB Hardware Debugging. Now, click on the Switch button to open the Debug perspective. In the Debug perspective, click the Resume button twice. Then verify that the project is running without any errors by checking the green running indicator at the bottom left corner. For demonstration, I've built a simple external LED circuit connected to D7 of the Arduino interface, which is wired to P103. Now, when the onboard user switch is pressed, the external LED will turn on.